Alright, for today's lesson, we're going to focus on the relationship between perpendicular lines and slope. So we've already learned about parallel lines and their relationship with slope. Perpendicular lines also have a special relationship. Just remember, perpendicular is when two lines cross. So I'm going to draw a little picture of it right here, and form right angles. So you're looking for that T shape with that cross where they form a right angle or 90 degrees. So we're going to do a very similar activity. We're going to plot some lines and compare some slopes between some different colored lines and the lines that are given. So just like with the parallel lines, we're given some lines, line A, line B, and line C, and they already have their points listed. So on line A, I have 0, 1, and then -5, 3. This is line A. Same thing for line B. These points are on line B, and then these points are on line C. First thing we're going to do is we are going to graph the blue line. So on my graph, I'm going to go over, start at the center, the origin, and go to 0, 2. So it's right there. That's the first part for the blue line. Then I'm also going to plot the next point, which is 2, -1, which is down here. And using my ruler, I'm going to connect those dots. Put arrows on the end, and then we're good. Next is the purple line. So I'm going to plot -3, 6, which is up here, and then -6, 5. Using my ruler again. Draw my line and put the arrows on the end of it. And then the last one is the orange line. So I'm going to plot those points, 4, 0, and 6, 5. 1, 2, 3, 4, 5, 6. And then draw my line through there. Alright, so we have our lines plotted. Let's look at our questions and see what our questions are asking us. So in this problem, they gave us the equation of line A, and they're saying it's y equals -2/5 x plus 1. The equation of line B is y equals 2/3 x minus 2. And the equation of line C is y equals -3x minus 2. So they've already done the work for these ones. We're going to find the slopes and the y-intercepts for these equations. So let's look at the blue line. Here's my blue line. To find the slope, I'm finding the distance between the 2 points. Since I'm going from left to right, this line is going down, so I'm expecting it to be negative. So I'm going to count how many spaces down and how many spaces over. So it looks like it's -3 over 2. So the first part of my equation, I can write y equals -3 over 2x, because that's the slope. And now I just have to find the y-intercept. So I look back at my graph. Here's the origin. So how many spaces up is the y-intercept? It's 2 spaces. So that means this is plus 2. So that's the equation for the blue line. I found the slope, and then I found the y-intercept. Looking at the purple line, which is next on our sheet, I'm going to find the slope between the 2 dots of the purple line. So again, going from left to right, I'm going to start at this point to go to this point. This is a positive. So how many spaces up and how many spaces over am I going? Looks like it's 1 over 3. So for my equation, I would write down y equals 1/3 x. And now we have to figure out, where is this graph crossing on the y-axis? It looks like it's crossing right here. So I can count from the origin, the center, and count up to see how high that point is. 1, 2, 3, 4, 5, 6, 7. So it's 7 units up. So my y-intercept is y equals 1/3 x plus 7. Let's get these both on here so you can see it again. So I did my slope, which was 1/3, and then I counted up how high was this point for the y-intercept on the y-axis. Last, we have the orange line. So here's a picture of my orange line. Let's bring it back over. See if I can get all this on. Here we go. So for the orange line, again, I'm looking at the slope between the 2 points. So again, they're going left to right. This line is going up. So I'm going up 1, 2, 3, 4, 5, and then over 1, 2. So it's up 5 over 2. So y equals 5 over 2x, and then this one, it's a little hard to see the y-intercept with this one. I didn't draw my line long enough, so I'm going to take my ruler out again, pull this up so we can see it. I see that I drew my arrow, and it looks like I should have kept drawing because I didn't draw it far enough. So if I pull out my ruler again, line it up, and extend that line, it looks like my y-intercept is right there. So I would count from the origin down how many spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I went down, it's negative. So the equation here is y equals 5 halves x minus 9. So again, I used the slope, and I found the y-intercept to get my equation for this graph. So let's do some comparisons and see what we can find out about the relationships between some of these lines. So the first question asks, which colored line is perpendicular to line A? So again, remember, perpendicular means they make that nice T shape where there's a right angle. So if I look at my graph, line A is this one, up on the left over here. As I trace over and I look at my ruler, I'll use my ruler just to kind of help. Notice the purple line, that's not making a nice right angle. That's too slanted to be a right angle. So we'll keep looking. The blue line crosses over here, but that's not a nice right angle. But look at where it hits the orange line. Look at how it makes that perfect T right there between A and orange. So I'm going to say that the line A is perpendicular to the orange line. And writing down the equations for both of these, we know the equation for line A because it's given to you. Y equals negative 2/5 x plus 1. And the equation of the orange line is this one over here. So now you should be thinking about what's the relationship between those lines. Let's keep working and see if we can find out. Which colored line is perpendicular to line B? So if I look at line B, let's go back to our picture. B is this line over here. We know it can't be the orange line because we've already talked about that one. Well, B and purple don't intersect on our graph. They will intersect way over in the top right over here somewhere. But nowhere that we see. So it looks like B's only option really is blue. If you look at it, blue and B are making that nice T shape right there in the center. So blue is perpendicular to B. And our two equations here, line B is y equals 2/3 x minus 2. And the blue line is y equals 3/2 x plus 2. Negative 3/2 x, plus 2. Again, think about the relationship between the slopes and see if you notice anything just yet. So then obviously the last line, the perpendicular to line C, has got to be purple because we didn't use that one. But let's just make sure on the graph that it makes sense. So here's line C. And the purple line is making that nice T shape where they're perpendicular. So the equation of line C is y equals negative 3x minus 2. And the equation of the purple line is y equals 1/3 x plus 7. So now we've got these relationships. Flip over your paper to the back side, and let's see if we can answer these questions. It says, what do you notice about the slopes in each pair of equations? So let's look at the first pair. Here are my slopes. Do you see anything, any relationship between them? Well, I see the same numbers, 5 and 5 and 2 and 2. The only thing that's different is that this one is the flip, where I flipped over the numerator and the denominator of the fraction, and it's not negative. This one is positive, so they have a different sign and the numbers are flipped. Looking at the second relationship, again, it's the same numbers, but this one has a negative sign and this one doesn't. And this one is the flip of this one. I'm looking at the third relationship. Again, I see a negative and a positive, so that's consistent. That's been the relationship so far. And then this one's a little bit different, but if I think about the way we can write 3, or negative 3, remember negative 3 can also be written as negative 3 over 1. Because remember, if you divide, negative 3 divided by 1 is still negative 3. So the flip of negative 3 is 1/3. So it looks like for each slope, for perpendicular lines, you flip the fraction and you change its sign. So if it's positive, it goes to negative, and negative goes to positive. So they are the slopes are opposite signs, and flip of each other. In mathematic terms, we call this the reciprocal. When you flip a fraction, it's called the reciprocal. Okay, what do you notice about the y-intercepts? Well, looking at the y-intercepts for each, there's no relationship. They're different again. The y-intercepts have to be different. So the y-intercepts are different. So what general statement can you make about the equations of perpendicular lines? The lines have to have different y-intercepts, and their slopes should be opposite signs and the flip of one another. So using that knowledge, let's answer these questions. Are y equals 3x plus 7 and 3x minus 8 perpendicular? Well, no, we said they have to have different y-intercepts, which they do, but their slopes have to be the flip. These aren't flipped. And they also have to be positive and a negative, so that one's a no. Are these ones perpendicular? Let's look. 2/3 and negative 3/2. Those are the flip of each other. And then the slopes and the y-intercepts are different. So that one's a yes. Name 3 lines that are perpendicular to y equals 1/2 x, y equals 2x minus 3. Just be careful. Remember, we can rewrite this as y equals 2 over 1 x minus 3. So then see if you can come up with 3 ways to get that lines that are perpendicular. So I know I have to flip the slope, and make it negative. And now I just pick numbers that are different for each y-intercept. Try coming up with 3 that are not perpendicular on your own, and then work on the practice problems for today.